I'll explain what it is in a second, but first of all I just want you to read that beast of a question there. What makes it a beast is it looks like there's not nearly enough information. Just have a read. So an old friend of mine has 3 kids and tells me that their ages add up to 13 and multiply to give my house number. After thinking for a bit, I say I need more information to decide their ages. She tells me that the eldest one is learning the violin. All of a sudden I can now work out their ages. And the question for you is why? What are their ages and what is the house number of the person speaking? Now, this looks weird. You think, how on earth could you have enough information? What possible difference could the violin make? Okay, but we're going to crack this problem with some very powerful problem solving techniques. Now the first one we're going to use just to get started is the cases strategy. The cases strategy, listen please, is for anything where there aren't that many possibilities. So like there's a famous puzzle about paths diverging in a wood, and there's somebody there and he always tells the truth or always lies. I can't remember what it is. It's in lots of fantasy movies. And you have to ask them a question or something. Well, there's only 2 cases. You either go that way or that way. Okay? Now, a lot of problems are like that. A lot of problems, there aren't that many possibilities, and so you can actually afford to write them all down. Okay? Now, this is an example. There aren't that many ways for numbers to add up to 13. Okay? Now, in a second, I'm going to get you to write them down. It'll only take you 2 minutes. But for goodness sake, be systematic, please. In other words, do it in categories. Okay? So maybe do all the possibilities that include ones, all the ones that don't include ones, whatever. The categories are up to you. The categories are just to make sure you don't leave any out, and so you can be sure when you're finished. Okay? But it's not that hard. I think there's only about 20 possibilities. Okay? Because if the numbers are whole, there aren't that many ways for them to add up to 13. Okay, so can you just do that now, please? Okay, so here are my here are all the possibilities. Okay? Now there's not that many. The answer has to be somewhere there. Okay? So what we do now is we come up with some clever way of restricting down which of those it can be. Okay? But the question was confusing for a reason. I mean, the question was obviously confusing. So what I'm going to do now is just a good old Dear Mr. Examiner. I'm going to admit that I'm stumped, and I'm just going to do something with those just because I can. Okay, hoping and praying that there's something in the mark scheme that rewards me for that. Now, if you look back to the question and you think, basically there are 4 operations in the world, what do you think would be the most sensible thing to do with those lists of numbers? Do not say add them, you'll just get 13. Have a look at the question and tell me something sensible that I can do with those.
Multiply them.
Multiply them? Is that because there's the word multiply there?
Yeah.
Yeah, that's perfectly good reasoning. Okay, so can you just multiply your numbers, please? Go. Arithmetic. Okay, so these are my products. Okay, now hopefully that just gets you 1 mark, which is worth it. Remember the 2012 exam, if all the people who got 0 out of 4 or 0 out of 5 had just managed to get 1 mark, another 30 kids would have crossed the grade boundary they were nearest to. Getting 1 mark out of 4 or 5 is a good idea. Now we're going to kick in another strategy, which I've actually told you before. It's called What's Special About the Numbers. Now you've used this before in a question where you had to notice amongst this great big list of terms that there was an A, B and a BA, and you had to notice that that wasn't an accident, that it deliberately got put there. Well, there's something extremely special about the list you've just got there, which is not an accident. Can you find amongst those 14 products which number is special?
36.
Okay, so Fern's saying 36. Why? It's the only one that there's 2 of. Okay? Right, now, I'm always telling you this, it's comment 1691. Just go back to the question every so often just to make sure you're actually doing what's required. The fact that there is a double instance of 36 explains one of the sentences in the problem. Which one? One of the weird things about this puzzle is now explained.
Oldest one's learning violin.
No? Katie?
Oh, so she tells me that the eldest one is...
How would that explain it? No, it's not as weird as that.
She needs more information.
It explains why she needs more information. We don't know the house number, but the person in the problem does. So this is the only possibility. This is the only possible explanation for why she needs more information. Because she's got a full list of all the possibilities that it could be. If her house number was 11, it would narrow it down to this. If her house number was 80, it would narrow it down to this. Okay, so this is a very powerful strategy when you think that you've got the whole wide world of maths at play, but in fact you don't. You've just got 14 possibilities. We've ruled out 12 of them now because it has to be 36,229 and 36,166.
Why though?
Because only that could explain why she doesn't already know the answer.
Oh, so it must be.
Yeah?
It must be 229.
Because her house
Yeah.
number is 36, and she goes, well, you've told me the kid's age is up to 13, so it could be any of these. You told me that they multiply to give my house number. How could she not know? If her house number was 20, it would be this combination.
But how do you know that it's not 20?
Because she needs more information.
Because there's
Therefore, it has to be the 36.
Because there's 2 times.
Otherwise, she
Because
would
there's
know.
two
She would
options.
Otherwise she'd know already.
She would
Yeah.
know. But
She
she
needs to
asked
narrow
for
it down
information,
more.
so it must be one where there's 2 options.
You cool?
Right.
Okay, right. So now, Amy, tell us what's the importance of the violin.
Because then when she says the oldest one, there would need to be an oldest one, and if 2 of them are 6, then they're twins. So it need to be the 229.
So that's the
Nine's
answer.
oldest
There's
one.
still
Okay? Now, Louise is correct. It's not a very well expressed question. Even when it's identical twins, there's still one who's a bit older. It should have said the one with the oldest numerical age, but that probably would have given it away. And it's also just weird expression. Okay? So this is an example of how some problems, which initially seem weird, can be cracked very quickly by using a very powerful problem-solving technique. And just listing all the possibilities that something could be is very powerful. Okay? Now, in your review assignments, I'm going to add some questions on this case of strategy. But before we do that, I just want to give you some practice at them. Can you look at, let's look at this number 9 together. Or whatever the last one is. Okay. So, there's some box. Girls, can you just quickly draw a diagram of that situation, please? Draw the box. It always helps just to get yourself in the groove by jotting some stuff down. There's never a better excuse for jotting stuff down than drawing a picture. Go. Just draw the boxes. Come on, get a wriggle on. It's not that hard.
What's 9?
So that's box A. That's box B. Yeah? And apparently 2 of the numbers move across. Okay? Now, the total of the numbers in box B, apparently, is now 4 times the total of the numbers in box A. So that will be 7 numbers. The total be y. I don't know, let's say it's 4x.
So
3 numbers. Let total be x. Okay, remember we try and use as few letters as possible. So I've used x and 4x because one needs to be 4 times bigger than the other. Now here's the thing, girls, there aren't that many ways for the numbers to move. Okay? Even if you listed all of them, I literally think there'd only be 10. Okay? Only 10 ways to pick 2 numbers out of this. Okay, so can you actually list all 10 ways, please? Go. Try and be systematic. It's not so easy with this one compared to the other one. There's only, I'm telling you with my maths teacher knowledge, there's only 10 ways to pick 2 numbers out of that. So write them down. Go. So what are all 10, please? Somebody's got them all?
2 and 3.
2, 3.
2 and 4.
2, 4.
2 and 6.
2, 6.
2 and 9.
2 and 9.
3 and 4.
3 and 4.
3 and 6.
Yep.
3 and 9.
Yep.
4 and 6.
Yep.
4 and 9.
Yep.
And 6 and 9.
Okay, now you just look through that and see which one works. Okay, now you can narrow it down. I think I overheard somebody noticing that we don't actually need to write down all 10, because what are these currently add up to? Just a bit of Dear Mr. Examiner. What do they currently add up to?
24.
So the current total is 24. And what's the current total of this?
31.
Okay, if this is going to end up being 4 times bigger than that, the numbers that move need to be pretty damn chunky. Okay, moving a 2 and a 3 is not going to do the job. Okay, so amongst your possibilities, concentrate first on the ones that add up to a fair bit. You'll find the answer in no time. So 4 and 9 adds up to 13. That would reduce that total to 11. And it would increase that total to 44, which does the job. So this thing here, that's a classic example of the naming, stating and equating strategy. I didn't actually end up needing it. Because we train you into thinking, oh, algebra's all great and stuff. We always train you into thinking that if you don't have enough information, then there must be something wrong with you, that you've not thought hard enough. These sorts of problems are increasingly popular. Okay? They're not going to be as popular for you as they will be for all the younger girls in the school. They're going to make the GCSE exam chocker with these. I think the year after you've done it. I think you're the last year that goes through under the old system. But I'm telling you, this will occur in A-level, and it will occur in your life. Situations where you just don't have enough information, you just got to list everything that could possibly happen and see if you can do it by elimination. Okay? So, so that's that strategy for today. I'll tell you about the extreme case strategy tomorrow. You can go over to the computer room now. Here is another example, which is obviously in a very unfamiliar setting for a GCSE or A-level maths student. It's about all these people who are lying. Now, the key question, as you can see, is how many of them are lying. So there's only 5 possible cases for that. Nobody's lying, 1 people are lying, 2, 3 and 4. They're the only cases. So yet another example of how when there's only so many things that something can be, you can just afford to write them all out. Now I'm just going to do a little table here, which is a very good trick. Okay, now I'm going to work out whether this person is saying something correct under each of the cases. If nobody's lying, then D'Artigan, who says 1 person is lying, is wrong. If 1 person's lying, then he's correct to say 1 person's lying. If 2 people are lying, he's wrong to say 1 person is lying. If 3 people are lying, he's wrong to say 1 person is lying. If 4 people are lying, that's the case as well. Athos. Exactly 2 of us are lying. Well, that would make that statement correct and everything else false. What about Porthos? An odd number of us is lying. Well, 0 is certainly not an odd number, so that will be correct. 1 and 3 definitely are definitely are odd, so those statements would be correct. So in other words, if 1 person was lying, remember these are the things that are actually the case. It's just that we don't know, so we've written all 5 of them. So if 2 people are actually lying, then he's wrong to say an odd number are lying. If 4 people are actually lying, then he's wrong to say that an odd number of people are lying. Now, Aramis. An even number of people is lying. Well, if he says an even number of people are lying and 1 person is lying, then he's definitely wrong. If 3 people are lying, he's definitely wrong. If 2 people are lying, he's definitely right. If 4 people are lying, he's definitely right. And I don't really know whether 0 is an even number. Nobody really knows the answer to that. Now, okay, now the whole point of this strategy is that by looking at what you've worked out, you can usually eliminate the possibilities, or at least reduce them down. Okay, under each of these, I can do a liar count. That's 1 or 0. That's 2. that's 2, that's 1, and that's 1. So the only situation where the actual matches what I've worked out is this column. So therefore there must be 2 liars. And therefore if we were answering the maths challenge, then okay, I was just looking at this and it seems there's 2 options, but if you read the question carefully, it says lying with the others telling the truth. So if we've just established that the answer is 2, then that could be an answer because the word or gives you 3 chances to agree with something. If that's the case, or both. I realise I have a mistake, but my liar counts are wrong. My liar counts are 3 or 4, 2, 2, 3, and 3. So amongst the 5 options, the only options where the liar count under the table matches the case that gave rise to that count are these 2. So the answer is 2 or 3, namely part C. Okay, so there's another example of using the cases strategy to crack a difficult problem.